Hello, this is Mr. Stansbury. I'm going to take you through the 18B assignment. Okay, number one, consider the three graphs given below, A, B, and C. Clearly, A shows a perfect positive linear correlation, B shows a perfect negative linear correlation, and C shows no correlation at all. For each set of points, find R using this really fun formula. Okay, on the math studies test, you get to use your graphing calculator. So I'm going to show you how to do this on your graphing calculator, which is much easier than this. So let's get rid of this formula here. We're not going to use that. And we're going to use our graphing calculator instead. Okay, so on your graphing calculator, we're going to want to go into stats. Okay, and what we're going to do is we're going to edit our points. Okay, so we're going to enter in. And I was testing this out earlier to make sure that it worked, but let's pretend you've got a bunch of data in here that you don't want. To get rid of that, you highlight list 1 and hit clear, and then push enter, and it'll go away. And then we go over to list 2, hit clear. Doesn't do anything until you push enter or you move up and down, and they're all gone. So what we're going to want to do in list 1 is list all of our x's. So x's are going to be 1, 2, and 3. So 1 enter, 2 enter, and 3 enter. And then in list B is going to be all our y values corresponding with the x value. So we got to start with the 1 where the x is. So we go 2, 3, and 4 for our y values. 2, 3, and 4. All right, now we can find our r value by going into stat, and we're going to go over to calculate, and we're going to calculate a linear regression with number 4. Okay, and that's going to actually give us our r value. It says y equals ax plus b, and actually gives you the equation of the line too. So the equation of this line, what this is saying is y equals 1x plus b is 1. So it's the equation of this line, not that they're asking for it, is y equals 1x plus 1. Starting at 1, your slope is up 1 over 1, up 1 over 1. So there's the equation of that line. Okay, and then, but what they're asking us to find is the r value, and there's our r value. Our r value is 1. So r equals 1, which means that it's a perfect positive linear correlation. Okay, if one of these dots was off a little bit here, then still might end up with this same equation, but it's just not going to give you, or at least a similar equation, but your r value will not be 1 because it's not perfect. Perfect is 1. If it's completely unrelated, then that would be 0. Okay, so comment on the value of r for each graph. So let's do this one here. This graph here, the r equals 1. Let's find the r value for this one. So we're going to go back into stat. We're going to edit. And then we've got 1. Look, our x values are still 1, 2, and 3, so we'll leave those. And now our y values are going to be 2, 1, and 0. So we'll do 2, 1, 0. Uh-oh, what happened? 1, 2, 3, and then we have 2, 1, 0. Not sure why that didn't work the first time. So now we go back into stat again, and we are going to calculate a linear regression. So you can arrow down, or simply just push 4. And now we do that. Y equals ax plus b, negative 1, because the slope is negative 1, and it starts at positive 3. Right? And then our r value now on this one is negative 1. Okay. Last one here. Let's see. Let's move this over so we can see. So values here on this one here. So we're going to stat. We're going to edit our points. So let's clear those out and clear these out. Let's see. We've got 1, 1. And 1, 2, so let's do 1, enter, 1, enter. And then we have 2, 1, and 2, 2. So we got 2, enter, 2, enter. Those are all of our x's. So we've got 1, 1, and 1, 2. So we've got 1, 1, and 1, 2. Okay, over here we have 2, 1, and 2, 2. So 2, 1, and 2, 2. All right, now we go to stat. Calculate our linear regression. Let's see what happens now. Y equals ax plus b. A is 0. B is 1.5. So they're basically saying that they don't know what to do with it, so they're just going to make this straight line here. And the important part here is the R value is 0. Okay, so now it asks us to comment on those here. Okay, the R equals 1, which means it's a perfect line, and it's positive, and it's going, well, it's positive, so that means it's going up. This is a perfect line, and it's going down. This positive one here isn't actually what, I mean, it does happen to be the same as the slope, but if we have a perfectly straight line that looks like this here, where we would make, let's see if I can make this pretty close to perfect line. I've got my little cheater bar here. So that there, the slope there is 2 and it's positive. The R value on that would still be 1. Okay, the R value is not necessarily talking about the slope. It's talking about how close that line is to all of those points. Okay, R equals -1 just means we have some sort of negative slope. So again, it could be here, here, and here. And if we were to make that line there, see how the line goes perfectly through all those points. That R value for that line there would also be -1. And since this doesn't have any relationship at all, the R value is 0. So the closer to 0, the less relation, not relation, but the less perfect the points fit the line that was given. And the closer to -1 or +1 is the closer that the points do actually fit onto that line. Okay? Okay. Let's put this into action. Number 3, scores awarded by 2 judges of diving competition are shown in the table. Construct a scatter plot for this data with Judge A score on the horizontal and Judge B on the vertical. Okay, I'm just going to pause and make this graph, and then we'll use that data to figure out the rest of this. All right, so here's roughly what the scatter plot would look like. Okay, so looks like it's pretty decently linear, and it's positive for sure. So it says copy and complete the following comments on the scatter plot. This appears to be positive. Okay, and looks like it is probably moderate. It's not super strong. I'm going to go with moderate. Correlation between Judge A scores and Judge B scores. That means that Judge A scores increase as Judge A's scores increase. Judge B's scores will also increase. Okay. All right. So let's calculate and interpret Pearson's correlation coefficient. So that's where we're going to put all of our data back into the calculator and see what it gives us for our R value. Okay, so let's do stat again. We're going to edit, and we're going to put in all this data. I'm going to pause and put all that in. Okay, put all of our data in. So now we're going to go back to stat, calculate linear regression, and we hit our enter here. And interestingly enough, here's our R value is 0.94. Okay, so calculate and interpret Pearson's correlation coefficient on that one there. So it's 0.943. 0.943 is our R value. Okay, so that means it's not moderate. That means it is strong. Okay, anything over a point, what was it, 0.75? So I looked it up in our textbook here, and here's our strength of association. So we look for the R squared value, and our R squared value is 0.89. Okay, so here, 0.89 would be very strong. Anywhere between 0.75 and 0.9 is a strong correlation. So again, this would be a strong correlation here instead of a moderate. 0.5 to 0.75 for the R squared would give us a moderate correlation. Okay? All right, let's move on to the next one. Number 3, restaurateur believes that during March, the number of people wanting dinner, Y, is related to the temperature at noon, which is your X value in degrees Celsius. Over a period of a fortnight, the number of dinners and the noon temperature were recorded. Okay, so that's all the data. Draw a scatter plot, calculate the R and the R squared for the data, and then describe the association between number of dinners and noon temperature for the restaurant in question. Okay, so I'm going to pause and draw a scatter plot, and then we'll go over we'll calculate the R and the R squared. Okay, so here's roughly what the scatter plot looks like. So if we want to go through and calculate our R and our R squared, we're going to pull our calculator back up again, and we will use, let's put this over here. And what we're going to do is we're going to take all this data, this is all of our X values and all of our Y values, and put that into our calculator. Okay? Remember to get in there, you just do stat, edit, and then now you want to put everything in to each of your list 1 and your list 2. List 1 is always your X, list 2 is your Y. All right? Okay, so put all of our data in there. So we'll do stat, calculate, and we're going to calculate our linear regression. Okay, push enter and then enter again. And here's the equation of the line. Y equals 2.24x for the slope plus 6.23 for the y-intercept. But really what we're looking for is we're looking for the R squared and the R value. So 0.74 is the R value and 0.55 is the R squared value. Okay, so calculate the R and the R squared. So B R equals 0.74, and then the R squared, I believe we were 0.55, weren't we? Yep, 0.55. 0.55 for that. Oh, looking at our table over here, we're right in here, so this would be a moderate positive correlation. Okay, so C is moderate and positive correlation. Okay. All right. Let's see. Let's move on to the next one. Excuse me. Number 5. It's been long thought that frosty conditions are necessary to set the fruit of cherries and apples. The following data shows annual cherry yield and number of frost data for a cherry growing farm over a 7-year period. So here's the data. Draw a scatter plot, determine the R and the R squared, and then describe the association. So I'm going to draw our scatter plot, and then I'll start us back up again. Okay, so here's what the data looks like on our scatter plot. So we're going to determine the R and the R squared by putting it back in the calculator, right? So I'm going to go into edit, and then we're going to put all of our data in. All right, so here's all of our data entered in. So we'll calculate that, stat, calculate, linear regression, and see what we get. So our R value is 9.98, well, basically 0.99, and our R squared is 0.98. So R equals 0.99, R squared equals 0.98. Right, and then on our table, that's definitely going to be our very strong association between cherry yield and number of frosts. So it's a strong positive association between cherry yields and the number of frosts. All right? Okay. Number 6, in a business advertised in 2002, a business advertised starting salaries for recently graduated university students, depending on whether they had a bachelor's degree or PhD, as shown alongside over here. Draw a scatter plot of the data, determine R and R squared, and then describe the association. All right, so I'm going to draw a scatter plot, and then we'll start back up again. Okay, so here's our scatter plot here. And then we're going to go in and figure out our R and R squared by pushing stat, edit, and then putting all of these in for our x's and all of these in for our y's. Okay, so here's all of our data entered in. I'm going to calculate, stat calculate, linear regression, and here we go. We've got our excuse me, our R value is 0.92 and our R squared is 0.85. And R squared is 0.85. Okay, so describe association between starting salaries for bachelor degrees and starting salaries for PhDs. Makes a pretty direct relationship between the two, but you're definitely going to make more on each one of these with your PhD. Okay, so it is a your R squared is 0.85, which, let's see what that is. So that is right in here, so it would be a strong correlation. Okay, all right, that's all there is for the 18B assignment. If you have any other questions, please feel free to ask in class. Thanks.